Okay, so let's have a look at this. These are all our rules. You know that the differential of sine is cos, differential of cos is minus sine, and differential of tan is sec squared x. Now, find the equation of the tangent and the normal of the graph. This where x equals 0, give your answer in this form. Now, first of all, we need to differentiate f of x. So first of all, f of x equals cos x plus e of x. So f dash of x. So the differential of cos is minus sine x, and the differential of e of x remains the same, e of x. Okay, now we differentiate it because we want to find the gradients of the tangent and the normal. And what you should know that if you got a curve, this is a tangent to this curve, and this is known as the normal, which meets the tangent at 90 degrees. Normally we call the gradient of the tangent mt, and the gradient of the normal is mn. And now, since the perpendicular, which you learnt in year 12, gradient of tangent times the gradient of the normal has a product of minus 1. And it's always nice to state that fact in the exams to let the examiner knows what you're doing. Now, at that particular point, all the action is happening there. Okay, so first of all, I'm going to say when x equals 0, what is the gradient? So first of all, when you differentiate a function, you get the gradient of the tangent. So I'm going to put the 0 in there. So the gradient of the tangent, sine of 0 is 0, plus e of 0, which is anything to the power is 1. So this is 1. Now, if this is 1, gradient of the normal is going to be the reciprocal of that negated, which is minus 1. Easy so far. Now, at that point, when I'm finding this equation of the lines, I need a coordinate point. I need that point where all the action is. I know that x is equal to 0. I need to find out what y is there. Now, what is y? Well, y is the function. So y equals f of x. This is the function. If I put 0 in this function, I will get cos of 0 plus e of 0. Now, cos of 0 is 1, as you all know, and e of 0 is also 1. So y ends up being 2. So what I do know that I'm going to put a line down here. All the action here, where the tangent and the normal intercept, it intercepts at the point x equals 0 and y equals 2. So that is the point these both lines go through and meet at different gradients. So now, the last thing I need to know is when I'm finding the equation of tangent and normal, I put it in the form of a straight line y equals mx plus c. So I'm going to write down y equals m, well, the gradient of the tangent is 1, so that's going to be 1x, just x, plus c. And if I do this simultaneously, I've got equation of the normal is going to be y equals minus x plus c. Now they both go through the same point, so I'm going to just sub that. Now I'm just going to put x, y, just so that I'm putting it in the right order. That's a misconception that kids put it in the wrong order because they just see that as 0 straight away. So be careful. So y equals 2, x is 0, plus c, therefore c must equal 2. And in this case, the same thing, put 2 there, put 0 there, plus c, hence c equals also 2 here. So that's it. You write down the equation of the line, the equation of the tangent, on this case, is y equals x plus 2. And on this side, the equation of the normal is y equals minus x plus 2. Now, it wants it in this form. So it wants everything bringing to one side and equaling to 0. So this can be rewritten as, if I'm just going to take that to the other side, you can rewrite this in the form they want it. You will lose a mark if you don't write it in that form, so be careful. You'll say x minus y plus 2 equals 0. So that is the equation of the tangent. Okay, you just brought the y over, and in this case I'm going to bring everything to the other side. X plus y minus 2 is equal to 0, and this is the normal. And that is how the cookie crumbles.